notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, Section 1, Number Theory and Computation. All 33 videos in that section have been published in their entirety on YouTube. Section 2, Consumer Arithmetic. All 12 of those videos in that section have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published in their entirety on YouTube. So as I said, that's 51 videos published on YouTube in their entirety. We continue now. Section 4, Measurement. This is the first of 16 videos, and hopefully we'll get that done in this month of December. Then next month, January 2025, Statistics. February 2025, Algebra. March 2025, Relations, Functions, and Graphs. April 2025, Geometry and Trigonometry. And finally, May 2025, hopefully by mid-May 2025, Vectors and Matrices. And that will take care of all the objectives in this syllabus. Reminder again that I have divided Section 1 into 33 videos, which have all been published in YouTube. The main reason for that is that this section, that is Section 1, forms the foundation on which the rest of the syllabus is based. How well you can handle this section will predict how well you will do with the rest of the syllabus. So please make sure you look at those 33 videos from Section 1 and know them fairly well. Reminder also that if you don't already know the times tables, you will need to know them, in the light that calculators are not allowed in paper 1. So these 12 videos from Section 2, as I said, have all been completed and published. And then these 6, which was a change of my plan. My original plan was to offer only the 33 videos from Section 1 in their entirety on YouTube. And as I said, as they form the foundation on which the rest of the syllabus is based. And then subsequent to that, from Section 2 onwards, only a few of the videos will be offered on YouTube in their entirety. The others will only be partially available as notification if you are subscribed to this channel. That was my original plan. Well, and if you wanted to see those complete videos, then you would have been redirected to another site where a reasonable subscription fee is required. That was my original plan. However, I changed that plan. That plan now becomes effective from Section 4. Now, if you are wondering why this generous, and I will explain what I mean by generous, change in plan, well, I really don't know. That's all I could say. It was just a thought, maybe inspiration, who knows? Anyway, don't look a gift horse in the mouth. You have 3 full sections available in their entirety on YouTube without sending you to another site that requires a charge. Now, why I use the word generous here, you may not realize it, but it takes about 30 minutes on average to prepare and publish each minute of one of these videos, one of these screencast videos, about 35 minutes, including the PowerPoint preparation and then the screencast capture and joining them together, editing, and then publishing. So if a video is 30 minutes, that would take about 900 minutes to prepare. So now let's go on to section 4, measurement. And this first video in this section is available in its entirety. So let me explain section 4. You have these objectives, 15 objectives. Objective 1, I have divided into 2 videos, conversion of length and conversion of other units. Objective 2, SI units, 1 video. Objective 3 into 2 videos, perimeter of regular polygons and perimeter of other shapes. Objective 4, 1 video that deals with length of arc of a circle. Objective 5, estimate area of plane shapes. That's video 7. Objective 6 itself, I have divided into 2 videos. But in this first part, I have also included objective 8, which says calculate area of circles. That's 6A. And then we can also calculate areas of triangles. That would be objective 8. We can do those 2 things in one video. And 6B, calculate area of polygons. That's video 9. Objective 7 and 9, remember we did 8 up there. Calculate area of sector and segment of circles, video 10. Objective 10, calculate surface area of solids, that's video 11. Objective 11, calculate volume of solids, that's video 12. Objective 12 deals with speed and distance and time, that's video 13. And objective 13 talks about margin of errors, that's video 14. And objective 14 deals with scale drawing, that's video 15. And finally, objective 15, solve problems involving measurements, and that will be video 16. Now, this is the part that lots of people think about of mathematics, defining area and conversion of units and surface area and those kind of things. Well, this is what we are doing as of section 4. Let's get started. Section 4, convert units of length, mass, area, volume, and capacity. And notice it says reference to section 1, specific objective 8. So we are here, but note that we did some of this already in section 1, objective 8. Then, of course, we have 5 more objectives here, followed by 6 more. And that would bring us to the end of section 4, measurement. So as I said, we are here. Convert units of length, mass, area, volume, and capacity. We did some of this already as it relates to length and to a certain extent a little bit on mass. And that is what this first video from this objective will focus on. So essentially, we will be reviewing for this video what we did in section 1, objective 8. And that would make up this video. Now, please look at it because I may say a few things here that I did not say in the previous video. That is the video based on section 1, objective 8. That may be new. This is actually section 1, objective 8. We are going back. Convert from one set of units to another, and then you have some things there about conversion scales and within metrics and so on. So specifically, we are converting units of length, and maybe you would also see mass and some other units, but certainly not area, volume, and capacity. Now, the metric scales are based on powers of 10. This makes it very easy to convert from one unit to another unit within the same scale. Example, within the scale of mass or within the scale of length. Now, there are some prefixes that we need to be aware of. Now, you have seen this before. You don't have to learn all of this. But the prefixes, if you start with a base unit here, if you take 10 of that base unit, you get deca, so that's 10. 100 is hecto, which is this. Kilo is 1,000, and so on. We will learn them as we go along, at least those that we need to know. And if you take units smaller than the base unit, you have deci, which is 1/10 or 0.1. There is also centi, which is 1/100th. There is milli, which is 1,000, and so on, micro, nano, pico. As you go up, they get larger, and you come down, they get smaller. So a millimeter here is smaller than a centimeter here. As you go up, it gets larger. Of course, a megawatt is larger than a kilowatt, because as it comes down, it gets smaller. Now, there is even more to this, but don't worry about it. I just show them to you. If you keep going up here above peta, which is 10 to the 15th, there is 10 to the 18th, which is exa and zeta and iota and so on. That's going up to 10 to the 24th. And if you keep going down below pico, you get femto and atto and so on, going down right down to 10 to the negative 24th. So no, you don't have to learn all of these. However, you do have to learn some, and these are the ones that you will have to learn. As we go along, we will learn them. They are not that difficult to learn. Once you have the base unit, the next lower unit is 1/10, which is deci. And the next lower one than that is 100, which is centi, then milli, which is 1,000, and micro. And as you go up, so you would have to learn these. Take some time and learn them, because we will not use them only for linear measurement. We will do something with these same factors here when we come to square measurements, which is the next video, and cubic measurements. So look at them and learn them. You will have to use them. Now, one little warning if you are dealing with computers before we go on. In information technology computers, 1 kilobyte is not 1,000 byte, as you may be led to think here, that a kilo is 1,000. No, 1 kilobyte is not 1,000 byte, but rather 1024 bytes. Because we are dealing with base 2 in computers, 2 to the 10th power is not 1,000. It's 1024. And the same thing goes for megabyte as it relates to bytes. It is not a million. It is 1,048,576, because it is 2 to the 20th power. And same thing goes for gigabyte. Down here, it is not 1 billion, but rather 1 billion there and something more, 73 million, some thousand and some, which is 2 to the 30th power. The problem arises if you buy an 8 gigabyte, say, flash drive. The manufacturers use this here to calculate the size of the flash drive. But when you stick that same flash drive in your computer, your OS uses these conversion factors here. So your OS is dividing by a larger number, and therefore the 8 gigabyte flash drive will show up as less than 8 gigabytes. For example, 2 to the 20th is this. It's not 1 million, it's 1,040,000 and some. So if the manufacturer divides by a million and the OS divides by this larger number, when you put your flash drive in your computer, it will show less than 8 gigabytes. Now, here is an 8 gigabyte that I actually put in this computer. Notice over here what it says. 8, that would be your 8 gigabyte if you are dividing by a billion. This will be 8 gigabyte if you are dividing by a billion. That's what the manufacturer does. So the manufacturer says it is 8 gigabyte. When I put it in the computer, it says 7.47 gigabyte. And that's because your computer OS is not dividing by this billion down here. It is dividing by this larger number here. So you get a smaller capacity by the OS standard. If you find this video useful and interesting, please like and share. Like and share. And you may even consider subscribing to this channel. Okay, remember just now when I told you you need to learn some of these things? Right now we are dealing with linear factors. And for the rest of this video, we will only look at these factors. But when you come to square factors, area, then we will square these indices here. If you say 1 kilometer is 10 to the third meters, then 1 square kilometer will be 10 to the sixth. And 1 cubic kilometer would be 10 to the ninth cubic meters. So you cannot escape learning these linear factors. Learn the linear factors so that when we come to the square factors and the cubic factors, all of those will become very easy. And as I said, you don't have to learn all that you see here, just a few from maybe from here to there. Now let's go on. So for the square factors, you will square, that is to say you would double the indices. And for the cubic factors, you will triple the indices and so on. But we will meet that in the next video. So these are the ones that you need to learn. However you learn them, if you start out with a base unit, deci is smaller than the base unit, and so on. So let's look at some examples. If the base unit is meter, we go upward. If we take 10 meters, we'll get decameter, written like that, D-A-M. And if you take 100 meters, you get hectometer. You take 1,000 meters, you now are dealing with kilometers, 1,000. Now, technically, 1,000,000 meters will be a megameter, and 1,000,000,000 meters would be a gigameter. But megameters and gigameters are not normally used with meters. They are commonly used as gigahertz or megawatts. That's going up. Coming down, if you have 5 decimeter, that would be 5/10 of a meter. If you have 56 centimeters, that would be 56 over 100 meter. And millimeters, 45 millimeters will be 45,000th of a meter. And if you are dealing with 25 micrometer, that would be 45 millionth of a meter. So you have to learn these. The base unit could be any quantity that does not have these prefixes in front of them. So if you are dealing with meter, that's a base quantity. If you are dealing with gram, that's a base quantity. Amperes, base quantity. Watts, base quantity. But from the time you start dealing with megawatts and gigawatts, then those are multiples of the base quantity. Now the basic principle, to carry a smaller unit to a larger one, always divide by the factor difference. And as I said, we will use length and maybe some others to demonstrate how this table can be used. So the next question you want to ask me is, well, what do you mean by factor difference? Okay, consider this quantity up here, giga and consider this one down here, micro. Now, giga means 10 to the 9th of the base unit. Micro means 10 to the negative 6th of the base unit. So what do? You would always subtract the smaller index from the larger one. In effect, you are dividing this one into that one up there to find out how many of this smaller one makes one of the larger one. So your factor difference is going to be 10 to the 9th minus this index here, negative 6. So 10 to the 9th minus 6, it would give you 10 to the 15th. So if you are going from giga, whatever, to micro, you will use this factor difference. Either multiply or divide, depending on which direction you are going in. The factor difference, always subtract the index of the smaller unit from that of the larger one. That is, you want to find out how many of the smaller units it will take to make one of the larger one. In other words, you divide the larger unit by the smaller one, and when you are dividing indices, you actually subtract them if they have the same base. And in this case, the base is 10. So the base is the same. All you need to do is subtract the indices to divide them. So in effect, what you are doing here, what we just did here, this 10 to the 15, is we divide 10 to the 9th by 10 to the negative 6, and we get 10 to the 15. That is our factor difference if we are going from giga to micro or micro to giga. Now, the basic principle, to carry a smaller unit to a larger one, you would always divide by the factor difference. So now, that's the two things. Well, three things. First of all, we need to know these factors here. Then we need to know how to calculate the factor difference. And the third thing is, if we are going from a smaller unit that is down here, going higher up, you will divide. Conversely, if you are going from a larger unit coming down, you will multiply by the factor difference. So let's quickly see how that is done. So from a smaller unit to a larger unit, you always divide by the factor difference. And from a larger unit to a smaller unit, you always multiply by the factor difference. So in these conversions, we need to know three things. We need to know what are these factors. We need to know how to calculate the factor difference. And then we need to decide whether we are moving from a larger unit to a smaller unit. We will multiply by the factor difference. And if we are moving from a smaller unit to a larger unit, we will divide by the factor difference. Now, in all cases, the factor difference is always positive. So let's look at some examples. Convert 305 centimeters to meters. So we are centimeters, we are here, and we are going here because it's the base unit. So we are moving from a smaller to a larger. Let's find the factor difference. From a smaller to a larger, we will divide by the factor difference. Let's find the factor difference. It will be 10 to the 0 power divided by 10 to the negative 2 power. And since you are dealing with indices, you subtract them. And so you get 10 squared, which is 100. So you already know that 100 centimeters make a meter. But we are learning a principle here. So 305 centimeter, you divide by the factor difference, and you get 3.05 meter. From smaller to larger, your answer will always be a smaller number. 305, our answer is 3.05. So let's look at another example. Convert 3,560 grams to kilograms. Now, I know this is not length, but still, it would demonstrate the point. We are going from grams to kilograms. So grams is here, it's our base unit, which is, we are going to kilograms, which is here. So we are moving from a smaller to a larger. We will always divide. We are moving from a smaller to a larger. We are going up. We will always divide. Now, what is the factor difference? Well, 10 to the 3 divide by 10 to the 0. So you will subtract the indices and you get 10 to the third power, which is 1,000. So it takes 1,000 grams to make a kilogram, which is obvious because kilo means 1,000. So now we will have to divide because we are moving from a smaller to a larger. So we divide that by 1,000 and we get 3.56 kilograms. From a smaller to a larger unit, the answer must be a smaller number. Example 3, convert 7,890 micrometer to centimeter. Okay, where is micrometer? Micrometer is here. And we are going to centimeter, which is up here. So we are moving from a smaller to a larger. So we must divide by the factor difference. Divide by the factor difference. Okay, so let's find the factor difference. 10 to the negative 2 divided by 10 to the negative 6. So you subtract the indices and you get 10 to the 4th power. That is 10,000. It takes 10,000 micrometer to make 1 centimeter. So we will divide by this. Divide that we are given there by 10 to the 4th micrometer per centimeter, and we get 0.789 centimeters. We move the point 4 places. 1, 2, 3, 4. From smaller unit to larger unit, your answer must be smaller. Example 4, convert 48,560 millivolts to kilovolts. So we are at millivolts and we are going to kilovolts, which is here. We are moving from a smaller to a larger, so we must divide by the factor difference. Well, what is the factor difference? This 10 to the third divided by 10 to the negative third. And so since it's indices, you just subtract the indices when you are dividing indices with the same base, and you get 10 to the 6th. That is to say, it takes 1 million of this to make 1 of that, so we'll divide by 1,000,000, which is 10 to the 6th. So we are dividing this by 1,000,000. You shift the point 6 places to the left, 1, 2, 3, 4, 5, add a 0. So you get this answer, kilovolts. From smaller unit to larger unit, your answer must always be smaller. Yes, and I know we are using volts here, but the same principle applies for length. 5, convert 548,560 milliwatt to gigawatts. Okay. We are milliwatt. We are here at milliwatts. We are going to gigawatts, which is way up here, 10 to the 9th. We are moving from a smaller unit to a larger unit. We must divide by the factor difference. Well, what is the factor difference? We will take that 10 to the 9th and divide it by 10 to the negative 3. To do that, we subtract the indices and we get 10 to the 12th. It takes that amount of milliwatt to make 1 gigawatt. So we divide that by the conversion factor, the factor difference. You get this, you carry it to standard form, and this is the answer you get. Remember, we are learning a principle here. Whether CXC will bring as difficult a question as this one or not isn't the question. The idea is we are learning a principle, and once we learn that principle, we can use it in all situations. Now, convert 4.5 kilometers to meters. Okay, so we are doing something different now. We are at kilometers, and we are going to meter. So we are moving from a larger to a smaller. Now, we will have to multiply by the factor difference. We find the factor difference the same way we did when we were going the other way around. So the factor difference would be 10 to the third power divided by 10 to the 0 power, which works out to 10 to the third power, which is 1,000. So now we will have to multiply by 1,000. So you move your decimal point three places to the right, 1, 2, 3, and you get 4,500 meters. So larger unit to smaller unit, your answer must be larger. So this answer, 4,500, is larger than 4.5. Example 7, convert 3.1 meters to centimeters. Okay, let's see how that goes. Meters, we are here, that's a base unit. So it's a base unit. We are going from meter to centimeter. We go from meter, we are going here. We're going from larger to smaller. Now, you don't have to use this table because most of you know that 100 centimeters make a meter, so you would just multiply by 100. However, let's learn the principle. To carry from a larger unit to a smaller unit, you will multiply by the factor difference. Let's now determine what is the factor difference, which would be this higher one here divided by this lower one here. And again, I'm saying when you divide the indices, you actually subtract. So 0 minus -2, and you get 10 to the second. That's the 100 that we were talking about. 100 centimeters make a meter, or a centimeter is 100 of a meter. So let's use this and multiply by the factor difference. 3.1 multiplied by 10 to the second power. Second power, you move the decimal 2 places to the right, 1, 2, and that gives you 310 centimeters. From a larger unit to a smaller unit, your answer must be larger than what you started with. Convert 2.8 decimeter to micrometer. Now, where are we? We are here at decimeter. And we are going to micrometer, that's here. So we are moving from a larger to a smaller. We must therefore multiply by the factor difference. What is the factor difference? We will divide this 10 to the -1 by 10 to the -6. So we subtract the indices, which is -1 minus -6, which gives you 5. So it takes 100,000 micrometer to make 1 decimeter. So in effect, we are going to multiply by 100,000. This is 100,000 here. We move this point 5 places to the right. That's 1 and 4 more. Example 9, convert 2.5 kilometers to millimeters. Now, some of you may convert kilometers to meters and then convert meters to millimeters by multiplying by 1,000 here, from here to there, and then multiply by another 1,000 from here to there. 1,000 times 1,000 is 1,000,000. So let's see if that will be our factor equivalent. We are going from a larger to a smaller. You must multiply by the factor difference. So that will be 10 to the third power divided by 10 to the -3rd. And so we subtract the indices and we get 10 to the 6th, which is 1,000,000. Okay, which is what we were talking about. So 2.15 kilometer multiplied by 1,000,000. You shift the point 6 places to the right. That's 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6. And so you get 2,150,000 millimeters. As I said, from a larger unit to a smaller unit, your answer must be larger because you are multiplying by the factor difference. Example 10, convert 1.68 gigawatt to microwatt. All All right, it's not length, but at least we are learning the principle. It's power. So where are we? We are here, gigawatt, and we are going to microwatts. So obviously, we will multiply because we are moving from a larger to a smaller. Now let's find out what the factor difference is. Now you understand why I was saying you need to learn these factors here. So the factor difference will be 10 to the 9th divided by 10 to the negative 6. And of course, that means you will subtract the indices and you get 10 to the 15th. It takes that amount of microwatt to make 1 gigawatt. Going the other way around, we will have to multiply 1.68 gigawatt multiplied by 10 to the 15th. So you shift the decimal point 15 places. That 6 will take 1, that 8 will take 1, and you add 13 zeros. Well, instead of that, just put times 10 to the 15th power, because this already has just 1 digit in front of the decimal point. Okay, so 1.68 times 10 to the 15 microwatt. And while we were using mainly length, we also use other units like watts and volts and grams to illustrate the point of this conversion from a base unit to one of the multiple units, whether it's multiple of powers of 10, positive or negative. Now, how well did you learn this? Now, remember I said you need to learn this table. You don't have to learn it all one time. Learn maybe the 2 smaller ones below, and then the 2 higher ones above, then learn the next one below, and the next one above, and so on. But you do need to learn it. And what the factors are here. 10 to the 9 giga, for example, 10 to the 3rd kilo, which is 1,000, 10 to the negative 3, which is milli, and 10 to the negative 6, which is micro. Okay. So let's see how well you learned it. 3,400 meter to kilometer. You are going from small to large. You're going from meter, base unit, to kilometer. That's up here. Your answer? Your answer is 3.4, since you have to divide by 10 to the 3rd. So if you are dividing by 10 to the 3rd, you shift the point 3 places this way, and you get 3.4 kilometers. Okay, next one. 450 grams to kilograms. This one should be very easy, especially in the light of the first one that we just did. So the second one, 450 grams to kilogram. Now this one should be very easy without looking at this table we have on the side here, because kilo means 1,000. So you are carrying grams to kilograms, if you forgot. So you would divide by 1,000. Shift the point 3 places to the left, 1, 2, 3. And what do we get? 0.45 kilograms. Now we are going from watt to megawatt. After you use this for a while, you will know that mega means a million. But in any case, 10 to the 6th. So 10 to the 6th power, divide by 10 to the 0 power, you get 10 to the 6th. So you divide this by 10 to the 6th. 1, 2, 3, 4, 5, 6. Shift the point 6 places, and you get 5.6 megawatt. Now we are going from centimeter to meter. We are going from a smaller to a larger. So we'll have to divide. We are going from centimeter to meter. And again, you don't need this table, because you would have learned that centi means 100. Or it takes 100 centimeter to make a meter. So you divide by 100. To the point 1, 2, 3, and you get 6.45. You could still use this to get the factor difference. 10 to the 0 power divided by 10 to the negative 2 power. So you subtract the indices and you get 100. Next one. Now this one is a little harder. 4,700,000 micrometer. Carry that to kilometers. So now we actually need this table. We are going from micro to kilo. So we take that 3 and we subtract a negative 6 from it, and we will get positive 9. From smaller to larger, we have to divide by 10 to the 9th power. 1, 2, 3, 4, 5, 6, 7, 8, 9. Add 2 zeros. 0.0047 kilometer. Next, 1.45 gigawatt to watts. Well, we know giga means a billion. But if not, please remember that this 9 here, and we're going to a base unit, which is here. So that 9 minus 0 index will give us 9. So we will have to shift this decimal point 9 places to the right, 1, 2, and add 7 zeros, which is that. Next, 3.56 kilograms to grams. Now remember up here we said kilo means 1,000. So some of these you will learn without having to refer to this table. So kilo means 1,000. But if you need to refer to this table, you are here and you are going to this base unit. So 3 minus 0 is 3. 10 to the 3rd power is 1,000. So you multiply by 1,000, you are going from a larger to a smaller, kilograms to gram, kilograms to gram, larger to smaller. And so 1, 2, 3. You shift the point 3 places to the right, you multiply by 1,000. Next, 3.45 meters to millimeters. Okay, meter is our base unit. We are going to millimeter down here. Now 10 to the 0 index, and you subtract a negative 3 index. So 0 minus 3, you get a positive 3, which gives you 1,000. So it actually takes 1,000 millimeters to make a meter. So in essence, you are multiplying by 1,000. 10 to the 3rd. So you shift this point 3 places. 1, 2, 3. Add a 0 here, and you get 3,450 millimeters. 9, 6.7 kilometers to millimeters. Now, so we are going from a larger kilo to milli. So we will have to multiply by the factor difference, which is that 3 minus a negative 3, which would give you 6, which is a million. So you have to multiply this by a million, 10 to the 6th. So you shift this point 6 places, that's 1, and you add 5 more zeros. There are your 5 zeros, and you get 6,700,000 millimeters. Of course, if you didn't learn this table, you could carry kilo to meter, and then carry meter to millimeter by multiplying twice by 1,000, which is the same thing as multiplying by a million. Finally, 2.4 millimeters to micrometer. So let's see where we are. We are at millimeters and we're going to micrometers. There's a difference here of negative 3 minus negative 6, and that would give you 3. So it takes 1,000 of this to make 1 of that, so we have to multiply by 1,000 since we are going from millimeter to micrometer, a larger one to a smaller one, multiply by 1,000, which is 10 to the 3rd power. So that 4 will take one of the zeros, and you add 2 more zeros. And so you get 2,400 micrometer. To review once again, just in case you are still not clear, you have to learn this table with these factors here. You will need to memorize this table. And as I said, you don't have to memorize it all one time. Larger units at the top, smaller units below. to carry a smaller unit to a larger unit, you would get the factor difference and then you would multiply. And so this is what we were learning. The main point is to convert from a smaller to a larger one, you must get an answer that is smaller. Use the appropriate factor to ensure that you will get a smaller answer. So as I said, converting within the metric scale uses factors of 10. You need to learn those prefixes, giga, mega, kilo, hecto, deca. Those are larger than 1. And then smaller than 1, deci, centi, milli, micro. Those are the main ones you need to learn. Now that was a review of Section 1, Objective 8. Convert unit of length, mass, area, volume, and capacity. In this video, we look mainly at length. Yes, we included a little bit about mass. The next video, we will deal with mass, area, volume, and capacity in detail. The same principle applies to other parts of this objective. Conversion of units of length, and mass. When you come to area, we will have to do something with those conversion factors before we subtract the indices, and volume. So we finished this, and we mainly reviewed Objective 8 in Section 1. So we have split this video into 2 presentations, length mainly, and all the others. And that brings us to the end of video 1, based on Objective 1 in Section 4. So you have the full video here.